Hello and welcome to Autology, the podcast that brings you the latest insights into automotive technology. I'm your host, Phil Amsrud, Senior Principal Analyst for the Automotive Semiconductor Research Area here at S&P Global Mobility. In today's episode, we're excited to have Ali Kani, Vice President and General Manager of NVIDIA's automotive team, join us to dive into some really cool advancements in automotive tech showcased at the 25 IAA Mobility show. NVIDIA has been leading the charge in innovation, and we can't wait to explore the cutting edge technologies that are truly shaping the future of mobility. We'll chat about the impressive progress in both hardware and software, including those all-important end-to-end solutions and software-defined vehicles. Plus, we'll take a look at NVIDIA's roadmap for system-on-chip hardware and software that are designed to boost vehicle performance and safety. As we navigate the ever-evolving landscape of electric vehicles, we'll also discuss how new architectures like separate domain controllers, zonal architectures, centralized systems are being influenced by the shifting EV roadmaps. Welcome, Ali.
Hey, Phil. Thanks for having me.
My pleasure. 2025 are years of big announcements, including Mercedes' launch with NVIDIA and the upcoming launch of Drive Thor. Is this a critical phase for the industry to demonstrate the maturity and value of ADAS solutions?
I think it's an important year for the industry, and it's largely because the software complexity and the richness of the algorithms available to put in self-driving cars is really maturing quickly. And so whereas traditionally, these cars would be launching and they would largely be, highway ADAS products, you can now build systems that can drive from, any location to any location, so highway, urban driving, and really make a customer feel safe. And so to be able to build a platform that has the compute and sensor set that allows you to build software that can essentially just make an end-to-end drive great and keep getting better over time. I think we're starting to see those systems launch, and it's exciting for the industry.
Do you think that, kind of, let's just say right now, with the 2025-26 launches, that we can say the software-defined vehicle is fully upon us? Have we transitioned to talking about it as something out there, the concept of, and now it's something that's on the road, and it's really going to start touching people's driving lives?
Yeah, I do. I think the architectures we're seeing in the launches right now from most of the OEMs, not all of them, are, you can call them software defined. I also call them AI defined. But I think the cars are set up to improve over time. You can OTA them safely and securely, and you're getting enough data from the cars such that if you learn something, you couldn't handle something the right way, you can capture that data, take it to the cloud, train on the failures, and have a software stack that actually solves that issue, and then you can OTA it to the car, and it's a better, safer experience for the customer over the life of the car.
During your IAA keynote, you talked about some metrics that piqued my curiosity. You talked about how long it takes to train a model, how long does it take to find an issue and then fix it, and how long does it take to gather data and process it, and you put those as important metrics out there. I was curious when you were talking about those, do you have any estimates as to what are good numbers for those three metrics to say I've got a really advanced system versus I've got something that's just good enough?
Yeah, I think so. First, I think it depends on the type of issue, because some issues are uh, faster to fix than others. But I'll kind of give you some simple metrics. We are able to update models that are driving our car um, um, within a few days. So that
Hmm.
it is common for us that within a week we can provide a new model that has gone through our testing and we believe improves the experience of a car, and the model can be generated multiple times a week. That's a lot faster than it used to be, a few years ago. And there are times that we capture an issue, that we have a bug that we have in a car. We can update, we capture that log, send it to the cloud. We see what went wrong, and we have enough logs of the drive that we actually can identify what the issue is. We can have a fix for that issue in the same day. Then we can test that issue in replay on the same exact
Wow.
scenario and show that we've proven it, and same day. And actually, there are times that I've been in a drive in the day, and maybe something happened that I didn't feel was a good experience, and we actually take a look at the log, find the issue, have a fix, and I actually can see the side by side videos of what went wrong. And then our new software on the exact same issue in replay now doesn't have the problem. And so actually, that can happen in the same day. Uh,
Wow.
and the reason why I say that it's not always the case is sometimes, it could be that your um, you have to build a new backbone,
Hmm.
which you sometimes do. That doesn't happen multiple times a week.
Sure.
Some of those changes take longer. So some changes take hours to make, and some changes take a few days, like just training a model on updated data. And then if you have a backbone, it takes longer time. But the point is there's so many issues. We're so far away from self-driving that development loop from finding an issue to root causing it to fixing it is so critical, because the person who actually can bring you in and show you how they're doing today, and then bring you in a few months later and can show you that the experience really has gotten better, um, that is the best AV company that exists. And I am telling one thing I will tell you is the capability of algorithms and our know-how is so far ahead that I absolutely do feel significant change, every month, from our drive. And that was not the case 2 years ago. 2 years ago, you're trying to improve your product experience, but maybe you wouldn't notice it for a few months. Maybe you said, "Hey, I kind of need 4 months to really
Uh-huh.
notice a difference." And now, absolutely, I feel like you should come to my shop. Let's drive the car this month, and then now let's drive it a month from now, and you can tell the difference, and that's
Okay.
that's super exciting for us in the industry.
Yeah.
um,
The three computer model that NVIDIA has, does that give you a unique ability to make those changes on that compressed timeline that you're talking about?
um, yeah, I mean, so first I would say that this this pipeline, we talk about the three computer problem, that is the essence of this development pipeline that helps. If you have a really good training infrastructure and a really good simulation infrastructure, it's the only way you can actually be fast, and get to full self-driving. And I think what I would tell you is if you asked me 6 months ago, because I think people did, um, when do you think we'll get to self-driving? At that time, I had told people, I think, well, robotaxis are kind of there already. We see what Waymo's doing in
Uh-huh.
certain cities, but I felt that passenger cars was not in this decade. But now, I just feel like the capability of these, vision language action models, think of like a large language model, but with multimodal video inputs, video, camera, radar, lidar. If you build that model, and then you have a safety guardrail stack underneath it to make sure that your model never causes an accident. Um, I believe it's absolutely something that's going to happen in this decade, because I'm driving in the cars. You have a simulation infrastructure that can create synthetic data for your long tails. So that also is a foundation model. It's not just the
Hmm.
foundation model that you need to drive a car. It's also the foundation model to create synthetic data, and the models you use to to automatically process and label your data. There's all these things that you have. There's all this AI in infrastructure um, in the cloud, and if you have the combination of rich AI capability in the cloud and algorithms in the car, I definitely think that it's going to happen in the next few years.
Neat. So, how has working with Mercedes and other OEMs have influenced the development and validation of the Drive OS stack for your ADC solutions? And then, kind of related to that, how about other ecosystem partners, especially on the software side, fit into that development? And is the result of all of that a stack that then that is kind of OEM specific, or does that create something that's a generic enough stack that you can then reuse it for multiple OEMs?
Yeah. Yeah. So, I mean, I think that's a great question. And, I think we're very proud of the fact that we've had the sort of the fortune and honor to get to work with, Mercedes, Volvo, General Motors, and Toyota, which I would say like these are the safety pioneers of the industry. And so what we've done is we've built an operating system, which I think the industry needs, an operating system we call Drive OS that is, ASIL BD, so ASIL D systematic. And the industry needs that, because at the foundation, safety is always built from the ground up. So, our SOC
Yeah.
needs to be safe and our operating system needs to be safe. On top of that, our partners build their own stacks. But if the core foundation is not based on, something that is robust and meets functional safety, then you'll never be able to build a platform. And so we've had the fortune of getting to work with all these safety pioneers, and all the learnings and all the software issues that we found and stability fixes we put in is there in our platform. And so the next customer gets to piggyback on all of those learnings, and they just start from where the other customers ended off when they went to production. So it's there for the industry. And then of course the other thing is we've also built the full stack ourselves.
Hmm.
So the application software that sits on top and the middleware that sits on top, but we've built it in a modular way such that you could actually just take our computer and our operating system, build the stack yourself, or you could come to us and say, I want more than that. I want, a safe middleware for automotive safety and security, and I want, level 2 plus plus or level 3 software, and parking and active safety. And NVIDIA has built all of that stack. And by having that end-to-end investment that we've made, um, we're a better partner for our customers, right? Our SoC is better, our operating system is better. Because how do you harden these things is, you have application software that you're developing on, and then you realize, hey, what tools do I need to develop more easily on this platform?
Hmm.
And we build those tools and then we give it to our customers. And that's one of the things we really pride ourselves in is the developer platform of Drive is very easy to program, and it's built to the requirements of the automotive safety and security. And so it just makes it really easy for customers to partner with us and successfully get to production on time.
Well, good. Thanks for going into so much detail on all of that, and I'm sure there's a lot more detail behind it than we could talk about in this segment. Um, so, from your perspective, or from NVIDIA's perspective, what's both the most exciting and the most challenging thing about these upcoming launches for you?
Um, I mean, I think for us, the most exciting is the infrastructure AI that is really kind of we're seeing pop in. I mean, you need a teacher model that trains the software in the car, and so we've released like Cosmos Predict. It's like a world foundation model that takes sensor input in and gives trajectory out, but it's not meant to run in the car. It's meant to be that teacher model in the cloud. And then you need a reasoning model that can think can take a scenario and actually provide chain of thought reasoning. So you break out a problem, and then you think, what's the best possible solution to this problem? So you think through options, and then you plan based on all the options. And then also you use that model to also give you captioning, such that if you want to find data, a reasoning model captions what's happening, and so then you can search for the data that you just captioned, right? That's like it's a car handling a fork, and so now you can easily
Okay.
find scenarios with forks or splits, um, and so that's super important. And, we've released a reasoning model, and just there's millions of people who have downloaded these open source models we've provided, and they're building their AV. And it's not just production customers; it's also universities and developers who
Hmm.
are not going to production, but they're working on uh, how to develop this kind of software. One day, their programs might go to production, but we're essentially the developer platform for the industry, whether it's a university or someone who's just interested, or the production platform that about our announcements with OEMs. So
So
I was just going to summarize that, there's just so much AI in infrastructure, and that's where we focus on, right? We're just trying to make it easy for our partners to take some of these tools and algorithms and APIs that we've enabled to build their own software and make it as safe as possible.
so if I heard you correctly in that last response related to what we talked about earlier about taking the lessons that you learn from one OEM and applying them to another OEM, you're saying that it's not just the lessons that you learn across OEMs within the industry, but it's lessons that can be learned outside of the industry, in academic surroundings and other
Of course.
places. Those lessons show up as well.
Yes, that's right. That's right.
End to end has been kind of the buzzword this year. That and probably agentic AI, but focusing on end to end right now. Um, how does NVIDIA's use of end to end AI differ from other? In use is not necessarily this line of code versus that line of code, but implementations or other things. How is NVIDIA's implementation of end to end different in your opinion than say others that are talking about it right now?
Yeah, I mean, I think the big difference is that, our model is open sourced and available for the entire industry to take and adopt to make their product. And, there's more than 1 million people who've downloaded our
Hmm.
Cosmos Predict model. Um, and so and so we're truly a open source platform partner for this industry. And that makes us unique, right? We're not trying to build software that is closed and only available for OEMs who are paying us. Um, it's open source. You can go on Hugging Face and you can download it, and there's no fee for it. And so we're a de facto platform for the industry, and we're providing these models to move the industry forward. And of course, it's great for NVIDIA too, because our partners take these models and they train them on NVIDIA GPUs in the cloud. And then often they take them and they run it on NVIDIA computers in the car. But again, you could train it on NVIDIA GPUs in the cloud, and you can also inference them on someone else's computer. We are truly an open platform, and I think that's what makes us unique. We think of things in terms of developers and ecosystems and helping move the industry forward. And we try to be a open partner. We try to let customers take what they want from us. So you don't have to. It's not like you can only take all of this. It's like, oh, you know what?
Hmm.
If you just want the SoC and the operating system, you don't want anything else. That's okay too. It's whatever is best for our partners is the right model. And another example of unique position, you don't even need to use us in the car, right? Like our biggest customer in automotive and partner is Tesla. They
Hmm.
don't use our computers in the car, but we help them in infrastructure. We help them with training. Uh, we help give them models that accelerates their developer flow. We help optimize their software to more efficiently run in the cloud. So they don't have to buy as many GPUs as they should. And that's a great partner. Like for us, it's more about how can we help you? What's the best? What do you need? And we've set up our products such that you literally can choose what you want, and we'll help you in the ways that you need help from us.
And am I correct in interpreting that, Ali? Is that's kind of the power of the three computer problem that we touched on earlier. Is you can be somewhat application agnostic because there are other parts of the system where you can bring solutions to bear, not just I've got to leverage everything to make that final sale at the end in terms of selling an SoC for a car.
That's right. That's right.
So we've talked a lot about the kind of the outward looking side of things, the relationship between NVIDIA and customers. Can we talk a little about how the MediaTek NVIDIA relationship fits into this? In that is it the case that MediaTek will do kind of the simpler systems, NVIDIA will do the more advanced systems? Is it as simple as MediaTek will do the infotainment? NVIDIA will do the self-driving, or just can you unpack that a little bit for us?
Yeah, I mean, I would kind of describe it slightly differently. I mean, first of all, NVIDIA is MediaTek is a world-class
Yep.
SoC company. They're number one in the world in mobile. They're number one in TVs and set-top boxes. So they're a very, like to us, they are
Sure.
world-class. And we have exciting capabilities on the GPU side and AI side, and so we've licensed our GPUs to them, our AI accelerators to them, and they're building products in automotive leveraging that hardware. And also we have Drive OS, which is a really great functionally safe operating system for automotive. And so they can take our operating system and put it on their SoCs where they're licensing our GPUs and our accelerators. And so, we've extended the reach of CUDA and Tensor
Mm-hmm.
RT to more computers. So for us, they're a great partner. And, so far the products they've done in automotive spans infotainment, but that doesn't mean that longer term they can't take the operating system and licensed IP that we've given them and move into ADAS. They're more than welcome to. We would love
Okay.
to see them in that space because then we're just extending the reach of our developer tools and APIs and libraries to more people in the industry.
Okay. Okay. I hadn't thought of it that way. So thanks for that perspective. Um, Changing gears in terms of kind of a big sea change within the industry over the last 12, 18 months is, the EV adoption rates, certainly outside of China, but the EV adoption rates have been slowing. And kind of the way we had modeled things at S&P in the past for new vehicle architectures was largely driven by when you introduce a new EV platform, that was going to drive the adoption of new architectures, that was going to drive the introduction of self-driving capabilities and other features.
Right.
Given the slowdown in EV adoption, that tight coupling is broken now. How do you see the OEMs or the industry in general kind of
Yeah.
responding to that?
Yeah. Yeah. I think the quick answer is there was a point where the industry started saying, you know what, it's going to be all EV. So they just
Mhm.
basically said, we have our legacy architecture and now we're going to move over to an NEV only, like a EV only architecture. And I would say what we're seeing now is that's unlikely to happen in the, short to medium term. And so what we see is a shift where, you want to have an architecture that is leveraged and flexible. So it can be EV, it can be ICE or hybrid, and a common core vehicle platform architecture can hopefully address all of those needs. And you saw, um, there are OEMs who have already built that. For example, the Mercedes architecture that has just launched is set up to be like that, right?
Mm-hmm.
It can be a hybrid, or it can be an electric, hybrid, ICE. Um, BMW had an architecture like that before, so not the new class that they just announced, but they
Yep.
had a multi-platform architecture. I think that's what you're going to see more of, because I think there's a recognition that the platform could go either way. And so you want to build the flexibility and also make it such that you're leveraging your investment, right? Like, having multiple architectures on every car line becomes a little bit costly. So in some
Yeah.
cases, it makes sense to standardize. And I think we're seeing that done very successfully in China, right? Like, look at BYD and what they're doing. It's a single architecture, and it can be electric, or hybrid. And that's very scalable for them. The customer
Right.
chooses what they
Right.
want, and they can support both architectures.
Regarding architectures, what do you think the industry's current thought process is in terms of, combining domains? So putting non-safety critical domains on the same controller, safety critical domains. At one time, that seemed everybody's goal was to have a single computer that did everything on the car. It's kind of feels like, well, that the industry may not be as committed to that as it was. What's your thought on where that's going?
Yeah, I mean, I think if I was going to give a simple summary of this, there was definitely there's an ADAS computer and an IVI computer. They're two separate computers, and now what we see is there's one there's a shift to have one computer system, but a different chip for ADAS and IVI.
Okay.
So it's kind of two chips, one computer. And then, we see some customers thinking in the entry, maybe that single unified computer can also be one chip. And then I think they just need to think through their software strategy, because then they break a single architecture, right? It's like it's a different kind of software in entry versus a software that sits kind of in the middle and high end. And so, people who want to kind of fork off their platform are thinking like that, and others, they don't want to do that because they actually want a single architecture. What's important about a single architecture? It's also a single stack. If you have a level 3 product, let's say it has two ADAS computers, and you design it where the one computer is actually an L2++ system,
Mm-hmm.
and the second computer adds sensors, and together it becomes a level 3 system. Well, that system is very scalable if really what you did was you built one system. When the second computer is not running, it's L2++, it's active safety, it's basic parking, and when both are running, it adds level 3. So really, you're qualifying one system, because the
Okay.
L2 and active safety parking is the same in the L2 plus only platform versus the L3 platform. But if you actually do something different, where now you also have something underneath it and it's like both together, that's a completely different platform. It's never the same software. And so now you're validating multiple stacks
Right.
for active safety. And one of the things I'll say is, when you have a software defined car, an AI defined car, and you need to support it over the life of your car, that cost is maybe misunderstood today, because it's substantial. And so you want to leverage, just like you want to have a vehicle architecture that can scale into ICE and NEV. You also want a software strategy that can scale from entry to high end. And when it doesn't, and you're now validating two stacks, you're taking on a huge burden in your engineering organization. And some customers should think twice about doing that.
Okay. That's interesting. So the kind of the old automotive methodology of kind of low, mid, high, you can still have that conceptually as tiers that you're trying to support, but you have to have a unified software strategy that
That's right.
undergirds all that.
That's right. That's right. And if you do it like that, I think you can manage that kind of a low and high kind of
Yeah.
segmentation. But I think if it's different software stacks, actually, I think that's just super challenging and super costly. And I think the industry will realize that it's hard to maintain that, because you don't stop when the car SOPs. You actually will
Right,
continue
right.
for 15 years. And now imagine doing that on different software architectures after 15 years. Because it's this generation, the next generation, and the one after. You're
Hmm.
supporting
Hmm.
so many, and it just becomes too costly, especially when you have to think about safety, right? If you have an active safety problem, you just want to fix it once, and you want it to
Yeah.
flow through your stack. And if that's not the way you've built up your vehicle engineering strategy, software engineering strategy, then it could really cripple some customers longer term.
Yeah. Is there anything else that you feel that we either didn't cover or maybe went over too quickly today that you'd like to add some volume to or introduce into the conversation?
I mean, I think the one thing, I just wanted to share, we see um, a couple shifts that is interesting. One, historically, what Tesla did was always, it's they're sort of, they have a different approach, right? They're not thinking about functional safety. They're thinking about SOTIF. They're thinking about performance. And I think there was a period of time when the performance of their cars wasn't necessarily, better or more safe. And so you could kind of dismiss what they're doing. But I think now there's a recognition in industry that their cars drive really, really well, and people are behind. And I think that's an interesting thing, is a self-realization. Wait, maybe there was something there that before we dismissed. And then I think the second thing is China is doing really great in autonomous driving, and now those cars are exported outside of China. At IAA, we saw a lot of Chinese OEM launches,
Yeah.
and there's really rich software in those cars, both inside the car as well as autonomous driving software. And so I just think that there's increased need for partnerships in the industry, because you can't ask, traditional OEMs, it's hard to compete with Tesla and, these Chinese software companies. And so they need to partner more than they needed to before. And so, there's only a few people who can build this kind of software, and can help partners build that kind of software. And that's why we're really excited about the opportunity for us.
Well, interesting. Interesting. Well, thank you. It's been great talking to you, Ali. That's all the time we have today. A big thank you to everybody who joined Autology.
It's my pleasure.
Um, Thanks. Thank you to all of our listeners for tuning in as well. We'd love to hear your thoughts for today's episode at our autology at spglobal.com email. You can find out much more at autotech.spglobal.com. Don't forget to hit all the subscribe, follow, and like buttons to stay on track with this latest Autology podcast. And we look forward to you joining us again on the next episode. Thanks for now.